To do molarity problems with solutions, it's important to understand the units of concentration. So units of concentration are going to be 1 mole per 1 liter, or 1 mole per liter is going to be 1 molar unit. So that's our molarity. That's how we determine molarity of solutions. So looking at the example 3, it says find the number of liters of 13 grams of NaCl in a concentration of 0.4 moles. So our 0.4 moles, we're going to change to 0.4 moles for 1 liter. So we're going to use that ratio in our calculation. We also need to understand the number of grams. Since we need to find the grams of NaCl, we need to know the number of grams per mole of NaCl. And that we get from our atomic mass unit. So sodium is going to be, sodium in this case, just going up to Na. Okay, sodium is 22.99, and Cl, when we go to Cl, is 35.45. So when we add those two together, we end up with the mass of the atomic number, the atomic mass unit of NaCl is going to be 58.44 grams per mole. So when we if I want to convert the grams firstly to moles, I need to then multiply by this factor, and I need to determine whether I'm going to times by 58.44 or divide. And again, that involves knowing my units, knowing the direction of my units, and then making sure that the grams go on the bottom here. So these grams cancel out, and so I'm left with moles as my unit. Once I have established that, then I use my molar concentration. 0.4 moles of NaCl to 1 liter. And again, to determine whether I'm going to times or divide, I just make sure that my units are going to cancel out. So moles on top here, moles on bottom here, they're going to cancel out, and I'm left with liters as my units. So working this out, I have times on top, divide on bottom, so this just becomes times 13, divide by 58.44, divide by 0.4, and that leaves me with 0.556. And the units then become liters because that's my units that are left over. STP gas problems, we need to make sure we understand that the standard temperature pressure is going to be at 20 degrees Celsius, or we have to convert this to kelvins for our ratio, so 293.15 degrees Kelvin, and the standard pressure is going to be 1 atmosphere, or 101.325 kilopascals. And in that situation, 1 mole of gas is going to take up a volume of 22.4 liters. Okay, so that's our standard temperature pressure. Now, to understand how pressure and temperature affect gas volume, it's important to have a sense of what's going on. If I increase the temperature, I'm going to increase the volume, and it's going to increase in a ratio of the new temperature to the old temperature in Kelvin. So we have to use this degree Kelvin. So we're going to base it on STP, or 293.15. So if we increase the temperature, we have to expect the volume to increase. So we need to make sure that the bigger number is in the numerator. The pressure is in the inverse, okay, or in the reciprocal. So as I increase pressure, my volume should decrease. If I decrease pressure, my volume should increase. Okay, so it works the opposite. So if I were to have a decrease of pressure, I would need to make sure that my bigger number is going to be on top and my smaller number is on bottom. If I increase the pressure, I need to make sure that the smaller number is on top, the bigger number is on bottom. Okay, so we need to make sure that we have a sense of which numbers go on top. Now, one thing that a check for this is when I do STP gas problems, I should see that the STP temperature and my STP pressure should be in opposite places. Okay. So looking at this example here, it says find the mass of O2 if you have 30 liters of O2 at 30 degrees and 90 kilopascals. So the first thing that we're going to do is we need to really figure out the volume at STP. So we need to bring this back to STP. So we're going to take our 30 liters of oxygen and to convert it back to STP. So right now we have a higher temperature. We need to bring it back to a lower temperature. So we need the lower temperature on top and the higher temperature on bottom in the ratio when we're going to multiply this. And notice that these units cancel out. So all we're doing is we're going to end up back with liters. So we use this ratio to find out the liters. And we do the same with the kilopascals. We're going to decrease the we're going to go from a decreased pressure to an increased pressure. So that means that we're going to get smaller. So we're going to go from 90 kilopascals to 101 kilopascals. So the volume should shrink. So our smaller number should be on top. Our bigger numbers should be on bottom. And notice that my STP numbers are in opposite. Okay. Okay, so we have once we've done that, we would, at this point, we have calculated the liters, and we need to then convert it into mass. So we're going to convert the number of liters at this point into moles by using our ratio of 22.4 liters in the bottom, because we need to cancel those out, and 1 mole of O2 on top. And then converting that into mass, moles to mass, we multiply by the molar mass. So 32 grams of oxygen for 1 mole of oxygen. We get that from our periodic table again. O2 is made up of 2 oxygens, so when we take a look at the mass of oxygen, oxygen is 15.999, so that we're going to round that to 16, and then we use that as our molar mass. Okay, so we have 32 grams per mole, and that's going to end up giving us in total 34.3 grams of O2.